Okay, recording started. So even I wanted to know what about so far your experience with DSA? Are you a bit comfortable with DSA or with these patterns? So if you see in the group, like we just recently started with uh, mainly with the two pointers and linked list, basic of linked list and sliding window.
Yeah, this one I am comfortable. Like basic ones.
Okay. I think sorry, I think one more guy is joining, but. Uh, cool, I approve the request. ओके तो आज हम लोग एक्चुअली वही देखने वाले हैं थोड़ा सा सो लेट्स लेट मी ओपन दी आवर रेपो yeah Amar is also there. Yeah, hi Amar. So we just starting the session, but what we have covered so far, and we'll just go through it some algorithm which we have covered through notes so far, and we'll see some problems around it. So let me share my screen once. Just a minute. Yeah. So let me sharing just a second. So please confirm my screen is visible. You can thumbs up. Yeah, perfect. Thanks. So see, so far we just started with some basic things. So let me tell you again the why we are doing this and the intention behind all this initiative. So just to the we should cop up with the basics and it's like DS is all about practice stuff. So even if you see the algorithms are not that much like tough or hard or it's like that, but it's just about if we take some time daily or maybe weekly, twice or thrice, and give some time and attention so for this, so you able to easily understand and you able to solve the problems. Like easy problem at least you can easily solve. Then we can gradually increase the level, like for medium level and hard level as well. So first we're targeting to first go through with the most important topics as far as the interviews are concerned in DSA rounds. So we are targeting some important patterns and algorithms, and as well as also some data patterns. Like so, in that manner, we are basically planning to proceed. So far, like we started with first, we have taken with the two pointers. So let's discuss today two pointer first. So I hope even you guys are on the group already, and maybe you have gone through it as well. But let's go through it again. So I'm opening here two pointers first. So even I will take the help of this pen and pencil to let's go through the algorithm first. So yeah, two pointers from the name itself, saying ki it is all about two pointers. We are maintaining the two pointers, right? And we are actually traversing kind of like mostly in the array, you can say, right? So we see like we already solved three problems here by using this approach, right? One is like your sum of pair, then we have container with most water and move zeros. We'll go through one by one. So let's discuss it ki what is happening here and how actually it reducing the time complexity. I hope ki you know the basics of time complexity, right? So here basically if you go with the brute force approach, so you maybe end up with the time complexity of O of n square. You can see it here. So because why this happens? So normally we take two for loops like nested loops. So obviously the time complexity will be go with the O of n square, which is obviously not the best approach to solve the problem, right? So in these kind of problem where you can reduce the time complexity to O of n, or even complexity also you can reduce with this kind of approaches. Like so this kind of approaches, I mean like even two pointer or even this sliding window and other patterns as well. So today we will discuss about this. So Why we use two pointer? To reduce obviously time complexity, to avoid unnecessary nested loops, and also, which I said, key also it helps to reduce the space complexity as well. To you can even solve the problems with the reduced space. So even if you see in the move zeros problem, you're passing the same array and you're updating it. You're not creating a separate array to copy the elements. Like we'll go into that problem, then you can relate more there. So what is the core idea behind it? Ki instead of using nested loop, we use two pointers basically, where you can say indexes as well. So two pointers basically we are maintaining that move strategically across the data structure. That data structure can be an array, can be a different as well, but here we are discussing in the context of array only. So those two pointer, based on some logic, based on some strategy, you will move those pointers, and accordingly you come to your result and you can solve the problem. So in this manner, you actually traversing your whole array once only, and then you get the final answer. So that's the best approach key you can solve in the O of n itself, like the time complexity. So I would prefer to move directly into the problem itself. So that would be better to uh, understand this algorithm in better way. So let me share my screen. We'll go through it here. Just a second. I think some more people joined in the meantime. Parth is there and one more is joining. And also there. Wait, let me add them. Pawan Kalyan. Pawan Kalyan तो इस एक्टर का भी नाम है, right? Yep. So yeah, hi Pawan, hi Ashwin, hi Parth. So we are just starting with this two pointer first. So we're taking first problem to solve move zeros at the end. Like, so I hope you are in the group and you've gone through these problems and you pretty much aware about it. But let's be understanding and discussing today these algorithms which we covered so far in our notes and resources and in the group. So I'm sharing my screen, just a second. Uh, yep, let me share this. Cool. Let me know once my screen is visible. And let me clear it. The screen is visible. You can thumbs up once.
Yes, Kushal, visible.
Yeah, perfect. Thank you. So let's go with the two pointers first. So two pointers. Okay. So first I'm going with this. We'll take an example of move zeros problem itself. Move zeros. So what we are doing here, so it's like you have an array, and suppose you have elements like 0, 1, 0, 2, then extra you can add 3, 4, 0, 5, something like this. And what we are expecting in the end, we want all non-zero elements here in the same order. Like here, if you can see 1, 2, 3, 4, 4, 5, and how much zeros we have? 1, 2, 3, 3 zeros. 0, 0, 0, something like that. So this is your basically input, and the output we are expecting this. Right. So how we can do by using two pointer? There are some other approaches also you can do with some brute force approach, and even you can introduce one extra array. So Suppose if you don't know about two pointers, then in general, what people do, the easiest way or brute force way you can say, they simply copy the first non-zero elements here, but one extra array they are using here. You can see one extra space you are taking basically. In this manner, what do? You first copy all the non-zero elements, and then you copying the no the zero elements in the last. So that way you can do, but it will take more extra space. Okay, and also this will need true traversal. First you will go with all non-zero, then with zero, and accordingly you are filling the new array. You getting it? This one, you can thumbs up once. But to optimize this, we are going with the two pointers approach. So to optimize it, what we are doing here in two pointers approach in the same array, I'm taking the same again. Let me write it again. This. Okay. So in the same array, I will update basically. I don't want to use extra space. And also in one traversal, I want to solve this. So in this way, what we do normally, we take two pointers, one left pointer, which we call it, and one more again right pointer. Okay. So what we do here, we actually again we are uh, we are here identifying the non-zero elements, and whenever you get any non-zero element, you will replace it with the zero element basically with the left pointer. So see how it will works. So initially the left right both pointing at the zeroth index. Okay, so no making sense to update it or swap it because both are pointing at the same. Then let's right will move normally in every iteration, right? So when write it here, when right pointer pointing it here, then it will find it the non-zero element, and left is still at zero. So it's a zero element, so you will actually swap it. So after swapping, what you will get it something like this. Okay, then the same this thing. Like after first iteration, I'm saying first iteration. And your now your left pointer is here and your right pointer is hit here. Because right again increase, right? So initially both are at here, then the right comes at one, then you swap it, then again it increase, then again right pointer here, left pointer here. Again you get a non-zero element, again you swap it. Then your zero comes here, your two comes here. Again you swap it, then again zero comes here, three comes here. Again you swap it, then again your zero comes here and four. And in like that way, you finally end up with this array kind of. I hope you're getting it. So in this way, you actually traversing only once and you updating the same array itself. You don't need a extra element which we are doing in the brute force like. So let me take you the code. You maybe more relate with the code as well. But on the paper or on while we're doing this as a pen paper approach, you're getting this algorithm. You can thumbs up. Anyone has any doubt, you can ask, or we can discuss any question around this. Fine. Other people, yeah, cool. Thank you. So let's go to the code as well. Let me open it here. So two pointers code. Sorry, move zeros code. And better I will open it in the playground. Yep. Just a second. Move zeros. I hope my playground screen is visible. Okay, you can thumbs up. Yeah, thanks. So now see what we are doing, which we have discussed recently. So again, let me tell you this I extra added. This even you can remove, but I will tell you what's the importance of this like. But if you see normally on the Google or any YouTube channel or something, normally you will find only this much code. That extra if I added, I will tell you why I added this. But first, let's understand this. What we are doing here, we are just identifying the non-zero element. If you see here, the left pointer is this, and this index is basically the right pointer, which I'm saying the right pointer. So here, the name is just changed. We are saying the here it is an index pointer. Even you can change the name index to the right one. Cool. So what we are doing here, two pointers are basically here. One is your keep it at the starting at zero, and another is like with your for loop obviously it will increment in every iteration. In every iteration, it will increase, which is basically your right pointer. And we are just checking at the right element. Basically, we are checking, right? Okay, whenever you get any non-zero element, you are just swapping it with the left one, right? Just that's it. We are doing, and you can see I can run the code. So I'm passing here to arrays, and you can see the output. You will find all the zeros at the end, right? You can see the output. But extra thing why we I added. So suppose your input is something like this. Let me tell you something like this. I added. So unnecessary swapping I'm avoiding. Whenever you already have some non-zero elements already in the starting, something like this. Even in the second example, you can see, not a problem. Here, and let me see if you see this kind of output. Okay, even in number 2b you can consider, but I'm again increase more element. So what in our algorithm is doing, we just see ki it whenever it find any non-zero element, it is basically swap with the left one. So initially you're left at the first pointer, right, at the zeroth index. But we know ki even left also is a right now non-zero element. So no need to swap these two, right? Left or right, both are non-zero, it will again swap it basically. So your 4 is swapping with the 4 itself. In that way it is, and then you are increasing your left pointer to 5, and your right also at 5 right now. Then again you are swapping it 5 with the 5. Doesn't make sense, right? Then again, then here it makes sense ki you will swap 0 with the 6. Right? Sorry, not here, but here I'm saying, yeah. Here it makes sense you actually replace 4 with the 0. Matlab you swap 4 with the 0. That makes sense. But till here, if you're again swapping it again and again, doesn't make sense. That's why I included this one. So what I'm doing here, I'm just checking if my left point, the left element and right element, if both are non-zero, so just proceed and increment the counter. So what happened in this case? Your left is also the non-zero element and right also the non-zero element, which is basically both are 4 right now. So you simply increment the counter. Then your left is also at the 5 and again right also at the 5, because in for loop right is automatically increasing, right, by 1. So again you are at here, but again both are non-zero elements, so no need to swap. Again proceed, matlab continue. Then again 6, again both are non-zero element, then again proceed. Then once you find the zero element, then makes sense. Then your right is at here and left is still at here, and then you actually replace it. So making sense this point. So to avoid just few bit of for these kind of inputs, you can add this, but even if you don't add, it doesn't make too much difference. Like this is also fine, because if you see in the large context, so again we are solving this problem in O of n and the space complexity is O of 1. So that is fine. Like no need to uh, matlab it doesn't make that much big difference. But it just my I thought like ki, why we are doing unnecessary swiping if both elements are non-zero, left and right both. So okay, cool. It's fine. Like everyone understanding this. Any questions around this? Anyone with the move zero? Yeah, Parth, Amar, Naresh, anyone? Yeah. So we can go to the next problem. You can thumbs up once. Is it okay? So yeah, perfect. Thank you. So similarly, we'll go to the next problem, which is basically container with the, or even I can take the this one, sum of pair as well. Let's go to the sum of pair first. So it is about actually sorted array. Again, very straightforward. So let me share the screen directly here. Just a second. Cool, you can see it here. Yes. See, there's a problem of sum of pair. Okay. But again, there's a condition here. The sorted arrays are giving you in the ascending order. So again, think about the basic common logic we can expect here ki what's the requirement ki you will get a one target number and you will need to find is any pair is exist which sum of pair is equal to this target value actually. So what we are doing here, if you see the approach, so again you can go with the brute force approach, which basically maybe time complexity of O of n square if you take every combination. So see here I put this point instead of checking all possible pairs, which will be end up with the O of n of square time complexity. We can even solve this with the O of n time. How we can solve this thing? With again using two pointers approach. So now we know it's already in the sorted order. So again, you will start with your left pointer and right pointer will be the end of the array. Here again, the approach is a bit different where in previous problem in move zero, you're starting left, right, both are from the zeroth index, right? But here your left is at the starting and right is at the end. Why we are doing this? You maybe understand this just a second. So even I can better explain you in this. Let me just on the whiteboard. You understand it better. Just a second. Okay. So let's move to here. Okay, hope my screen is visible. So now we'll move to this problem, which is basically your target sum problem. Okay. Target sum I can say, or even I can say sum of pair also. Both are same only. Cool. Sum of pair problem. Okay, so let's take an example again. You have input something like this. Let me take an example. So you have a array of 10, 20, 35 and 50. Okay, and your target number is here right now 70. Now you obviously you can easily tell key is there any pair exist. Obviously there's a pair exist, right, which we can say 20 and 50. If you sum these two number you will get this value, right? But again, how to solve this problem with the code? So we can simply see, but again, it's a very small array, so you can quickly say, but suppose there's a thousands of elements, okay, and then how you maybe can see like, and you can tell key is there any pair exist or not. So that's come into the picture with the algorithms and this coding solution, right? So what we're doing here again, so here the approach is a bit different. So let me again write this out. So here your left pointer is starting from starting index and the right pointer is starting from here. And now what we are doing, we are just adding left and right and seeing uh, is it greater than the current matlab, target value or smaller. So now sum this 50 plus 10, which is basically 60, right? Which is nothing but smaller than 70. If it is smaller than 70, so now we know it's a sorted array. So if we increase the left pointer, we'll get the more, you can say, bigger elements, right? So right now we know our sum is actually less than the target value. So we need to increase a bit our sum, right? So we'll actually increment the left counter and we'll move to the next element here. Now you again sum 50, 20. So which is you get 70 itself. So we check if we already get the target value, you can simply print and you can break the loop. But suppose if you don't get, suppose let me take some another example. Suppose you have element like even 10, 15, 20, 35, 40 and 60. And now your target value may be suppose 75 you can say. Okay, something you can say like this. So for this, now what we'll do again, we start with here left and your right. Like now left and right total is 70. 70 is again less, right? So you increase your left pointer. Then again you submit 60 plus 15, you get 75. So your problem is solved. But I want you, okay, let's go with the 55. That- So I give you, I want more iteration actually. So that's why. Okay. I want, yeah, we are taking example of 55. Okay. So again in the first case 70, which is actually bigger than 55. Now you actually reduce your right pointer. Why? Because we need to decrease the sum. We don't want to increase the sum. So to decrease the sum, we know again it's a sorted array. So if you move your left pointer left side, matlab you decrease your right pointer and you go with the lesser smaller element, obviously you get a smaller sum, right? So you now your left right pointer will be at 40 and your left pointer stays with the 10. So 40 plus 10 again 50. So now your sum is smaller. Then you again increase your left pointer, which is 15. Then finally again you get the 40 plus 15, which is basically 55, right? So in that way, this algorithm is working. But again, in one traversal, you finding the sum. So getting this approach like with using two pointer in one traversal itself, you basically until when you are doing you here actually we are going to use while loop. So till we'll go in the code while you can say left less than right. You can traverse like in the array. So at the end, suppose in the end you have an example. Okay, suppose 10, 20, 30, 15, sorry, 45, 60, and 90. And my element is suppose 33. Suppose 33. Okay. So we know there's no pair exists with 33. So what at the end, what happened? Your left is still at 30 and your right is 45 at the end, right? Because you start with here, the sum is bigger, so you will decrease it. Even your left is still not here, maybe it's here only because you decrease your right element till you actually get it here, you can say. So till your left matlab less than right, you can traverse the whole array. And if you don't find any pair, then you return ki there's no pair exist. But if you find any pair in between, you obviously tell the pair is there and you can print it and then you can break the loop. So I hope you're getting this algorithm. You can thumbs up once. Any question around this? Anyone? Cool, fine. So we can move to the code as well. Just a second. I can show you the code. Let me open this problem here. Sum of pair. Yep. Okay, in the code also you can see we are doing the same thing here. And as I said here, we use while loop. You say why even in for loop we can do no, but here actually it's not like you are every time you are increasing your right pointer, right, or left pointer. It's just like it's strategically you're moving. Either you can move the left pointer in iteration, or even you can decrease the right pointer. So it depends on the final outcome you are getting, right? So that's why we are not going with the for loop here. Here for loop doesn't works, right? You're getting this point. That's why moving me. That's why here we are using while loop. So you can see in the code what we are doing. Again, we are checking the left element and the right element. If it equals to target, then best like you find the pair and you can print it and you can break the loop. But suppose your sum is less than your target element, you need simply increasing the left pointer, right? You increment the left pointer, perfectly fine because your sum is still smaller. you need a bigger element, so you will increase the left pointer to get the sum more, right? And suppose your sum is smaller than the this, or sorry, if your sum is greater than this, matlab your current sum, which is basically left pointer right pointer value of sum is greater than your target value, then you want to decrease your sum, right? Then you basically decrement the right pointer to get the smaller elements, right? Because it's a sorted array. Cool. I hope you're getting this. I can run and I can show you. So in the first input, we actually having a pair with the 70 value, but in the next thing, we are don't having any pair. So you can see the output also once. See, I hope the output you can see. And first we have the pair 2050, and in the next there is no pair with the target value of 73. Cool. I hope two pointer is fine, everyone. With this question, you can thumbs up once. Yeah, Parth, Amar, Jaya, Ashwin. Yeah, cool, perfect. Thank you. So I will move to the sliding window. I'm skipping this one question, which is container with most water. You can yourself also you can go through it once, right? Because we already covered two problems here. So let's move to the another algorithm, which is sliding window algorithm. The name itself saying, let me sorry, this let me share my screen here once. Okay, sliding window pattern. I hope you heard about this pattern. Again, very frequently asked pattern and very important pattern from the DSA round perspective. So if you see, it's all about window thing, okay, right? And there's a very famous question which we are right now going to see, substring wala question, right? Longest substring without repeating characters, which is basically longest substring with non-repeating characters. You can say. So sliding window is all about you are actually having a window with obviously with a fixed window size or maybe a dynamic window size. So this question which we are talking about, longest substring, which is a basically dynamic window size. Here the window size is not fixed, but there are questions where you have a condition of key you need to find in this much window only. Matlab your window size is like maybe 3, 4, 5, whatever. There is some window size is given. So we'll see in the coming session and in our notes later on also with these kind of problem with having a fixed window size. But right now, today we are going to see this problem, longest substring non-repeating character, which is of type of dynamic window size. So how this works, like sliding window pattern. So you are actually maintaining one window, and in that window you're checking ki everything is fine. If something is not aligned, then you can update your window basically. So let's understand this pattern through the question itself, so that would be better. So let me take you to the problem itself. Here you can see you will given any string value, and you need to tell ki is there any matlab, you need to tell the maximum length of substring exist which is having non-repeating characters. So you can see the string here. What you can see, like how much you can see longest substring without non-repeating character, which is ABC. Even you can see ABC or even CAB, doesn't matter, both are same. But the point is the maximum length is 3 only, right? Of any non-repeating non substring, you can find it here, right? You can thumbs up once. And even if you see the this kind of example, BBBB, so here obviously only one character you can say the max length, because obviously every character is repeating. So let's understand this. Let me take you on the whiteboard, how this is working basically. So let me just a second. Uh, yeah, let's move here. Sliding window. I hope my screen is visible. Sorry. So sliding window. Okay. So what we are doing here, I can let's go through this question first. longest substring. So here, if you can see, uh, even in the string format, or matlab we can consider it as an array basically. So I'm considering string as an array, right? If you see internally string array, both are like same, similar, right? So let's take an example of this itself. Any string we can take, A, B, C, D, E, F. I want to give you one example. Wait. Take something like this. So it's obviously whole string. I'm giving in picture of the context of array. So now you can see the what's the longest substring here. So obviously this one you can find, right? This one. What happens next? It's not working. What? Just a second. Battery is there. What? Just a second. Tell me what happened exactly. Cool. Let me just a second. अरे अभी चलेंगे. ठीक है. So fine. Okay, so now what's happening here? You actually maintaining a window. So first you start with your A element. Okay. Again. Okay. Okay. A, then B, then once you find any repeating character, here you can see first repeating character you find, right? In the context of ABB, right? If I say we are starting with A, so once you move A, B, then in first you find this thing. So now you can see, okay, इस बात को समझने का try करना कि you're starting with the starting of the string, but again understand in the context of substring, okay, right? Substring is always in continuous, right? You can't be like a substring like AB and then CDFs like that. You can't do, right? That you can't do, right? So whenever we find any non-repeating character, we actually moving our left. Right now, left pointer is like here, and you can say right pointer is like here at the end of this. Now the right pointer is at here. Yeah, here right pointer, here left pointer. So whenever you find any repeating character, you're actually increment your left pointer here. You're removing a, then again you're checking. Again you have a repeating character in this substring. Again you cancel out the left pointer and you're increasing left pointer. Then now you move to the right pointer to the next one. Now if you consider BC, it's fine, it's non-repeating, right? Then again move ahead, E, it's still fine, BCE, then D again fine, and then F. Till this, it's fine. So, and every time you're moving, you are actually updating your max length you find so far. So in this case, if you can just start with the AB, your max length till the time till that time 2. But now in this case, you can see we having right now the count is 5, right? Our maximum non-repeating character substring length. Then again you find C, which is again actually I started with hand as well, but now pencil working. Pata nahi, this weird behavior I'm getting. But fine. So see now if you again find E here, so E is again repeating character in this whole string, right? So you again move forward your left pointer. Then again, if you see this thing, again E is repeating you this move. Then again E is repeating here. So till this you cancel out all the characters. Then your substring starting with here itself again. So DFC E again the 4 length is fine, but again you will encounter with the E. So doesn't make sense. Then again you cancel all the previous characters and you start with here. So in this way, like actually it works. I make it a bit clutter, but I hope you are getting this my point. We'll move to the code. You understand it better. So what we are doing exactly here, we're starting with the start of the string and we're saying how much we can go far with the non-repeating characters, matlab with the unique characters. Let me write it again. A, B, C, D, F, C. Okay, so we are actually, so we are seeing key from starting the string. Unique character AB is fine, but once you get any repeating character, you canceling out the previous one because it doesn't make sense because you can't hold this value. You can't say like me this. So sometimes people get confused with this. Ki you can say ki Kushal, okay, B is repeating now. To remove B, why you are removing A? But bro, we need to check in the context of substring. Okay, so doesn't make sense if I cancel the B, we can't move with this A, B, C. Like this can't happen, right? It should be in continuous, right? So in that way, if you understand this, so that's why we actually cancel out the left ones and we move with the right ones. Again, if you see the BB doesn't make sense, we cancel out the B and then we move ahead with the unique character. B, C, E is fine, D is fine, F is fine. So till this is our the longest thing. Then again you can encounter C, so it doesn't make sense again to hold the left characters, so we cancel out the left characters. And then we see still holding now it's all our unique characters, so it's fine. Then move ahead like this. So let's move to the code. But you getting on the paper the algorithm? You please thumbs up once. Yep, perfect. Thank you. So we'll quickly see the code of this sliding window. Let me open it. Longest substring. Yeah. So I hope my screen is visible. Xcode. So what we are doing here, you can again see, which I was explaining on this whiteboard. So you can see whenever, so this is actually for cancelling out the characters, and to maintain the unique character set, we are maintaining here by using set. As we know in set, only unique characters can be stored, right? No repeating value or characters you can store here, right? So set is basically for that only, to maintaining the unique values. So whenever you are starting your traversing, so you can consider it here like you're moving here. See the example. Let me increase the size here. So like this in our input, you can see AB is fine. You insert the element, you move away. Okay. And again, it's a for loop. So right pointer increment by default, right? and left when you will increase the left pointer whenever you find any repeating characters. So first you will move ABC is fine. Till then you will insert the character ABC fine. But once you get the C, which is repeating, the fourth one here, then you actually start, you come into this loop. So inside for loop we have a while loop, which is nothing, just to remove uh, the initial characters whenever we find any repeating characters in the substring. So what we are doing, which we discuss in the here on the whiteboard itself. So whenever you get any repeating character, like here you find the C, so you start removing A, B, uh, and C as well. All three will get removed. So now, like, doesn't make sense to hold this substring, right? Because you already find the repeating character here. So you discard the whole substring basically, until unless you find only the unique characters from here, the beginning. Then you start again your substring from here, like CBAD. This is fine. Again, you get the D. Again, you like cancel out the left. You move your left pointer till it here, like till you find only the unique characters are existing in your substring, which is basically you need to move it from here. And then again, you are saying the D, E, B, S, F, and even B. This is the, I think, longest one, the five substring characters. You can even see the answer here. I think five is the longest substring here. Right, you getting this point? So here you can see 5 is the right answer. So this is the substring basically, which you can see the longest substring with the unique characters. So you're getting it. Okay, sorry, I told you wrong. DEBSF only. This is the 5. B obviously repeating here. So this is the 5 characters as a longest substring, you can say, with unique characters. Right, getting the algorithm. So just about whenever you're getting any repeating characters, you're simply discarding the initial characters, and or even you can say you are discarding that whole substring basically, and you're moving ahead with the left pointer. And whenever you're getting any unique character, you're simply adding it. But whenever you're getting any repeating character, you simply like moving ahead and you're discarding it. So in that way, you maintaining your window, and you can check. So you can see in every step, whenever you are adding any characters, you are checking your max length till now. What's the max length? So it's basically maintaining a maximum number, right? We whenever we find any maximum number in an array, right? In the similar uh, pattern, we are actually maintaining the maximum element so far. So maximum length, you can say so far, right? So suppose initially ABC is the max length is 3, but when you move ahead with this length, which is basically of 5, then your 3 is the 3 max length is updated to the 5, right? So at the end, you will end up with the result of 5, right? Because after that, there's no bigger than 5 substring, right? I hope contains method of set is O1. I think so. I need to check. I'm not sure, but yeah, maybe. I think it's O1 only. Yeah. Cool. So all good with this. So this is a better approach. Suppose if you don't go with the sliding window, you go with the brute force. Again, you end up with the nested loops, and you will have a O of n square. Or even you have any better approach without using sliding window, you can tell. Here we can see in one traversal we can do it this. So it's like O of n. You're solving this problem, right? So here you can say the time complexity basically here is O of n, and space complexity also you can say O of k, but that k depends on how much size you're taking of sliding window. That you can say, but the point is time complexity is O of n only, right here. So in one traversal you can find out the answer. There's no nested loop as such. Yeah, cool. I hope you got this algorithm. So we quickly go through the linked list basics, and today we can wrap up the session then. Anyone, any questions around this? Anyone? So even I shared some easy problems with sliding window. You can go through it, and let me open that doc as well here. So I would recommend ki you can go through those problems. Just a minute. Mm, Easy sliding window problems. Yeah, just a second. Let me open it here. Cool. I'm opening the doc here just a second. So if you once understand easy sliding window pattern, it's really easy pattern. It's nothing but as such complex. So now you can see, you can easily find. So here you can see I'm telling you know there are problem with the fixed uh, fixed size of window, and there's a problem of dynamic window size. So now we just see which is basically category of dynamic window size, because there the window is not fixed. It depends on it can be like a dynamic, right? You are increasing and decreasing the window. But here if you see, there are problems where you given you the size fix, like the fixed size of window. So here there's one problem where you need to find a maximum sum of sub array of size k, and that k is given you. So you can see there is one example. I hope my doc is visible, right? You can thumbs up once. Yeah, thanks. So here you can see the problem. Here you have an input array, and there is a fixed size is given, which is a k, and k is basically here is 3. So in every 3 sub array size of window, you can see the what's the maximum sum you are getting. So you starting again with the 215, and you will check here, and then you are ending up with the this is the actually maximum sum you're getting, which is basically 9, right? So you can simply solve with the sliding window pattern. I hope you already got the algorithm. So this is very easy problem. If you can recently solved with the string non-repeating character, if you understand this, so this is very easy for you. Similarly, we have more problems like to find out the average of subarray. We found out maximum number of vowels in that substring of size k. These are actually all our fixed size of sliding window pattern problems. Okay, then similarly minimum you can find. Similarly, you can find some threshold and how much values are more than that or greater than that or even average. These kind of problems we can look into it. Then this we recently we have seen, which is of like longest substring with non-repeating characters. So these are all are the easy problems. You can just go through it once, and if you find any issues, anything, you can discuss in our group. Okay, similarly, I would recommend you to solve some problem with the two pointer approach as well. Okay, already we seen the two problems. I hope you also understand this problem, and you can even solve more problems based on it. It is very again easy problem. With the two pointers, you can easily solve it. So cool. Any even questions so far? Anyone? Then we will move to the linked list, the basics of, and then we'll wrap up today. So let me open. Anyone? Any questions? Or you can thumbs up once. Good with the sliding window and the two pointers. Yeah, perfect. Thank you. So let's move to the linked list. So okay, now we are also targeting some data structures. So even we need to cover some important patterns, and we're starting with the easy patterns, but also we need to understand the basics of the data structures which are existing right now. The basic data structures, which I'm starting with the linked list, which is very basic. I hope in your college time or even in our uh, previous any DSA now you faced it, or even anyone, but like you come to this kind of data structure, right? We know about it like linked list, stack, queue, tree, uh, graph, these data structures, right? We'll come to one by one. So I have added stack here as well, but sorry. Today we discuss only linked list in very short brief. So what is linked list? How it works? So linked list is nothing but like you have a kind of this data structure where you have a data and the pointer to the next node. You can say I'm talking about right now only the singly linked list. I'm not talking about the doubly linked list or circular linked list. Okay, so first we will discuss only single linked list. And if you compare linked list with the array, so normally people even people ask this question on this or uh, debate on this thing, ki, why it is better than array, in which context basically. Sorry. So whenever you if you see an array, it's a contiguous kind of it's a continuous like memory and contiguous elements in a continuous manner, right? So there, if you insert anything, you need to shift other elements like, so it's a expensive operation. Sorry, excuse me. Yeah. So whenever if you see in array, अगर आप कुछ भी insert delete करते हो, you need to shift entire elements. So in the behind the scene, it is happening actually. So that's why it's called an expensive operation. Expensive operation. But similarly in linked list, we simply update the pointers. So it's basically you can say a lighter operation, and there's no need to shift the remaining element. Like so, that's the main advantage of linked list. Other advantages are also there. You can go through it once, but one basic advantage or basic difference I'm saying. So how linked list works? Say like this, you can say the data structure here 10, 20, 30, 40. These are the four values you can say inside the linked list. And every data have a also the address or the pointer of the next value you can say. So 10 having value 10 also, and it this 10 node also having the address of the next node, and next node is basically 20. So 10 is pointing to the 20, then 20 is pointing to the 30, then 30 pointing to 40, and then 40 is pointing to nothing. Like there's a nil pointer basically. So you can say there's a linked list is ending it here. Okay, so it's starting from 10 until 40 you have the values, and then there is no one next to the 40. Okay, so 10 is basically a head node. We call first node as a head node. Basically we always have a head pointer on the first, and whenever you traverse, like let me show you the traversal here. So first see the code basically. So normally in this way we have a linked list implementation. So you can implement using normal in this manner. Even there are some other ways also you can do, but some basic implementation we'll talk about right now. So if you can see what is happening here, there's a class of list node. In class you have a value which having a value of integer right now, but even you can change this value type, right? You can even have a value of character, you can have a value of string or any other object, any whatever, right? So it can be of any type, right? But basically it having some value. And the next is basically your next pointer. So next pointer is basically having a reference of the next node. So okay, so in every node you're having one value, and you have a next pointer which is actually referring to the next node. Okay, so something like that. So whenever you traverse a linked list, what you're doing here, so you know the initial pointer which is basically the head pointer. So you can see in the traverse function what we are doing here. We take the current pointer here, like I will better to explain on the whiteboard this as well. So it is better, let move to this here, just a second. Let me share my screen, just a second. Yep. So for traversing, I'm just explaining, and even for how to add or delete a node as well. So it's working right. Yeah. So let me एक मिनट मैं इसका डिसेबल कर देता हूँ, just only pencil can draw. Yep. So let's move to the yep. Let's move to here. Again, it's not working. ये पता नहीं क्या हो रहा है इसको, कोई नहीं, चलो उसको फिर से डिसेबल करते हैं अपन. कूल. ठीक है, तो what is happening, suppose you have like this, okay, and you want to traverse. So 10 is pointing to 20, then 20 pointing 30, 30 pointing to 40, then 40 is pointing to nothing. So basically even don't write anything here. So you have one head pointer, I'm saying it here as an edge, and we actually initialize one more pointer here which is current pointer, which we call it as a current pointer in the context of or in the terminology of linked list. So current pointer starting with the head pointer, then current move to the next, and you print all the values. Okay, you're traversing and you're just printing the nodes, node value, you can say. So current start with the head. So current pointer is initially equals to head. Then current is moving to the current dot next. You can say like this. So current is moving to here because current, because you see can here, 10's next pointer is what, 20, right? So current moving it here. Then what, 20 का next कौन सा है, 30, right? So 20 मतलब right now current equals to current का next. So now current move to 30 and then finally at 40. So till then, till when you will do, until unless you will find out the nil pointer. So nil pointer is basically 40 is pointing to nowhere, right? So like that way it works actually. I hope you're getting the traversal part. I will go with the insertion and deletion as well. Just a minute. We are talking about कि it is easy here, like no need to. Okay, now again 10, 20. This are now. Suppose you want to add one element between this 20 and 30. Suppose you want to add 15 here. So what you do simply, you traverse till 20, okay, till your current pointer. Then you simply make your pointer update. 20 will point to 15 and 50 will point to 30, like this. And remaining is as it is, like no need to update, shift anything. Like so in array, in the context of array, whenever we insert any element, we need to shift all other remaining element, like, right? But here we just need to traverse till 20 and you simply update the pointer. It's basically is all about updating the pointers. So it is more easy, matlab more lighter, sorry, not the easy word I will say, but it's more lighter operation if you compare with the array, in the context of insertion and deletion. Similarly, suppose if you want to delete any element, suppose here now you have, wait, suppose now you have 10, 15, 25, 30, 40. Now I want to delete this 30 element. Okay, everyone is pointing out right now. So for deletion, you just need to update this 24 pointer. You simply update 25 pointer directly to 40. That's it. So now your linked list is basically 10, 15, 25 and directly 40. You just need to update the pointer, right? 25 next pointer right now. Initially it is pointing to 30, right? But you simply update the 25 next pointer to directly 40 and that's it. Like you just need to update the pointer. So 30 is automatically delinked basically, right? You're getting this point. So it's simply deleted. You can see this like in this way. I hope you're getting this point. Like insertion deletion, it's just about updating the pointer. And if you're not comfortable with linked list, I would recommend you go through the code and a basic implementation once you will get more comfortable. But I hope on whiteboard and on pen paper base you are getting this algorithm. Sorry, not algorithm. You're getting this data structure, the fundamental of linked list. You can thumbs up once. So in coming, we will add some more linked list problem like which are famous. So we'll add it later on and we'll discuss it later. But till now, like we just seeing the basic implementation, basic traversal, and basic addition and deletion of nodes. Hope everyone is getting it. Naresh, Jaya, Ashwin, everyone. Yeah, cool. So we can wrap up today the session and thank you everyone for joining today's session. And again, I will tell you कि main इसके पीछे intention यही है कि we do practice on weekly daily purpose and at least we move ahead. अगर जैसे what I found in DSA, अगर हम कुछ नहीं करेंगे तो कुछ नहीं होगा. तो वो our level will not get increased at all, right? To increase the level, we need to practice DSA. एंड कभी भी फिर कोई डीएसए राउंड अगर आ जाए, कोई हैकर रैंक टेस्ट एनीथिंग, तो वो एक फियर ना हो अंदर. तो एक अगर आपके फंडामेंटल बेसिक थोड़े अच्छे हैं, तो इफ यू सी इवन आई होप कि एवरीवन इज हियर राइट नाउ, मोस्टली पीपल आर सीनियर सॉफ्टवेयर इंजीनियर्स. सो फॉर सीनियर सॉफ्टवेयर इंजीनियर डीएसए राउंड्स आर बिट एक्चुअली इजी एज कम्पेयर टू फ्रेशर्स. आई होप यू नो दिस थिंग. सो अपने को बहुत ज्यादा टफ क्वेश्चन सॉल्व करने की जरूरत नहीं है, बट एटलीस्ट सम बेसिक डिसेंट लेवल पे अगर आपका है डीएसए, यू कैन इजीली क्रैक दोस डीएसए राउंड्स, either even online tests or even live programming, whatever it is. So utna level at least we need to achieve, right? So we'll go through weekly purpose, daily matlab patterns. We'll adding gradually, and you can also contribute to the same repo, and you can also add your problem and do involved in discussion and participation. I would recommend you everyone. It will be healthy and better for everyone, right? So we gradually add more patterns and more data structures. So like we are lined up with the stacks. Like similarly, we added linked list, we add stack and then tree, graph, queue, these things like in coming days and weeks. And similarly, we add more patterns there also, like backtracking, dynamic programming, monotonic stack. All these, there are a list of patterns which are again frequently asked and more important as far as the interviews are concerned. So cool. So that's it today, and thank you again. We'll see you in the next session. And be active in the group and do participate, do solve the problem, and go through these topics through the resources, through notes, and through blogs and article and videos. Yeah, cool. Thank you, bro. Thanks everyone. Thank you.